In this video, we'll be running through the steps required to create a fantasy village scene in Unreal Engine 5. This scene will be built using various add-ons, tools and assets packs that are available for the Unreal Engine. We will begin by building a grey box scene in Blender, moving over to Unreal Engine and gradually adding the assets to the scene. This will not be a step-by-step tutorial going through every little process in fine detail, but rather looking at the overall approach to doing each part of the scene. When creating a scene in Unreal Engine, it can be useful to create a grey box version of the scene first to make a quick mock-up so we can get a feel for how our creation is going to end up looking. We should put this scene together quickly, and it does not have to be perfect. Here, we're using a map of the village of Homlet as a reference for our scene. The map is imported into Blender as an image, and it's laid flat on the XY plane, and we can change the view to look down from above. When the image is in the desired location and scale, we can change the settings so that it cannot be selected and moved unintentionally. We then create a plane to represent the ground and scale this to the size of the map. The river and tracks can be marked on the plane using the knife tool in edit mode. Keyboard shortcut is K, and when we've created the cut that we want, we press enter to complete the action. The river and track sections can be removed from the ground plane using the separate by selection method. Keyboard shortcut here is P. The trees come in various sizes, and I've categorized them as tiny, small, medium and large. A low polygon tree can be created to represent the trees that will be replaced by actual tree meshes in Unreal Editor. The buildings are represented by low polygon meshes. Optionally, we can apply basic materials in Blender so we can get a better idea about the layout of the level. The low polygon meshes are exported from Blender as a single FBX file that can be imported into Unreal Editor. The main thing that we need to do is to change the path mode to copy. The other settings are most likely to be suitable for our workflow. We create a new level in an Unreal Engine project and save the map to a maps folder in the content folder of our project. To import our grey box level, we use File and then Import into Level, and this will add the meshes to our scene. We can go about creating folders and subfolders to organise the meshes assets into natural groupings. This will be helpful if we want to look at a particular type of asset in its entirety. Check the scale of the imported objects and fix where required. For example, the trees may be at an incorrect scale. In the sections that follow, we're going to be looking at how to do some of the activities, but not going down and doing every single step, every last bush, etc. We can create our landscape using the Unreal Engine tools. I have used the Brushify Smart Brush system, but any alternative should work just fine. In addition to deforming the landscape, I've added distance meshes to improve the scene and make it have a sense of depth. The Unreal Engine built-in sky system is a good starting point for creating the sky and weather system. In this map, I'm using the Ultra Dynamic Sky system, which is available on the Fab Store to control the sky and weather for my level. In our fantasy village, we need to have roads or tracks. We can create these by adding splines to the landscape and applying the Brushify pack roads. Change from selection to landscape mode and then select manage and splines. Control and left click to add points to the spline. Select all the spline points and then change the half width to have a wider or narrower road. The side fall off controls how quickly we blend in with the surrounding landscape. Next, select all segments and then scroll down to spline meshes and add a mesh. The mesh is S_road plane, and also add a material override such as MI road pebble. Adding rivers and streams to our level will improve the look and make it more realistic. To do this, we need to enable the Water and Water Advanced plugin. We add a water body river to our level, and then we accept creating a new water layer. Alt and drag on the gizmo to create new sections of the river, and then rotate appropriate to get the shape you want. We add a shallow water river to our level, and then within the properties we look for source river water bodies, click on the dropper and then onto our water body. We can use the utilities to either reset our river or to bake in the simulation. The trees and bushes in the level have been added using the procedural content generation plugin. The trees in the central part of the village have fixed locations but random properties such as meshes and size. The trees out in the forests around the village have both random locations and random spawn properties. There are 4 sizes of tree in the level: large, medium, small and tiny. Each tree has a tag associated with it, such as tree large, so that the PCG graph can pick up the locations of the tree and do the random spawning. The forest areas are defined by closed loop splines, and these also have tags on them so that the area can be picked up by the PCG graph. For the fixed tree locations, we start off with the get actor data, and this needs to look at doing actor selection by tag. The locations are then passed into transform points, so a random rotation can be applied along with a random scale. The output from the transform points is passed to a static mesh spawner. Here there's a mesh array of different meshes that can be spawned. For the randomly spawned forest areas, we need to use the get spline data node, and this also has a tag in it to pick out the particular area. The spline data is passed to 2 spline samplers, and these have different interior sample spacing for the trees and the bushes. This passes through transform points to pick up some random variation. A difference node with a binary density function ensures that the trees and bushes do not overlap with each other. And finally, the static mesh spawner generates the meshes at the points with the random variation. In our medieval village, there are a number of different buildings. I will demonstrate building a house, and this is the starting point for a large number of the buildings in the village. First up, we drag one of the walls into place, and let's say we're looking to build a house that's 3x2 units. We then Alt and drag on the gizmo to start building up the different sections. When we go around a corner, we just need to start to rotate our walls into place. So we switch between the move and rotate. Now that we've got the walls in place, we need to put our floor tiles down. So if we have a wooden floor, we can drag that into position, and then we just need to adjust it so it lines up with our walls. Follow the same process of Alt drag out, and now that we've got two next to each other, we can select them both and follow the same operation. So that's the starting point for our house. As a minimum, we at least need a doorway and a door so we can get into the house. Select one of the walls and delete it. We then go and find our plaster walls again, and we look for our single doorway. So we can now drag that into position. Snaps where we want it to. A little bit fiddlier when we want to actually put the door in, so we need to do a bit more fine tuning. You find a door mesh, drop it into place, and now if we just move our camera, we can see that we need to go down to a slightly lower level. Snapping from the 50, we can drag the door into a position that we think makes sense. Just need to get it up slightly, and we can no longer see the gaps around the door. So this is starting to look more like a house now. It's a similar process if we want to create a window. So first up, we'll clear some space, drag our plaster wall in position. We need to do a rotation, and then just move it around to get it back into the middle. So what we then also want to do is to drag some half-size walls into position, again rotate them, and then move them into place, or drag to put something on the other side. So now we've got the window in the middle. We look for windows, we find our wooden window, which is the one for this example. We want to rotate it, and then we go to a different level of snapping so that we can try and get it into exactly the position that we want to. Next up, we want to put a roof on the house, so we go above, make sure that you're in the correct snap dimensions, and drag a corner piece into place. Not quite precisely where I wanted it, but I can drag it across until it's in position. I can then Alt drag to move the next piece over, rotate 90 degrees, and then move it back into position. So I need to do this a couple more times so that I can get the four corner parts of the roof. Then lastly, I need to get some side pieces. And then we just need to move these into position on either side. Lastly, we need to add the lower roof part on so that we have an overhang that covers the wooden beams. As you can see, it's a pretty straightforward process once you understand how the modular pieces fit together. To add a little bit of life to the village, I've added some farmyard animals. These animals have a very basic AI where they graze in a particular position and then periodically move to another position before continuing with their grazing. This animal AI system can be found in a large number of tutorials on YouTube, so I won't go too far into the details of it. We can use an animation blend space to smoothly move between the idle grazing animation and the movement. We then have a behavior tree which controls our movement between the two states of the grazing and then moving to a new destination. The blackboard has a variable for the destination for the roam. We have a blueprint for our animal, and this is where we specify the animation blueprints that's used. The animation blueprint itself has an anim graph, and this is where we use the ground speed to specify which part of the blend space we use for the animation. So this has been quite a basic look at creating a medieval village scene in Unreal Engine using a variety of assets and tools available from the Fab store or within the engine itself.